Good morning all. Thank you for giving me your time to listen to our webinar on risk reduction measures together with our partners, Fortress Interlocks. Here in Underwoods, we'll be honoured to work with you, our friends and partners, using our expertise to ensure your risk reduction products, correct protective measures to ensure your machinery is compliant. As you can see, we are a company that works together with our customers and with our partners the risk reduction measures. We can provide complete solutions from all our partners. Over 35 years of experience working in safety. And as we can see from the next slide, that we have a complete range of products that will be able to suit all the requirements you have. Without further ado, I'll hand you over to Eve, who is going to run this workshop for Eve.
Thank you very much, Phil. Yes, so as Phil said, we're going to talk through kind of a little bit about risk reduction measures. I'm not obviously in the kind of 30 minutes or so I'll be hopefully keeping you entertained in that time. We're not going to be able to cover kind of exactly which risk reduction measures you should use at every moment in time, but hopefully go through some of the considerations that you should be thinking about and how you can maybe make some decisions as to which risk reduction measures might be suitable for different applications. So risk reduction measures kind of in ISO standards, it's a little bit complicated because it actually comes up, there's not like one handy standard to look at. So you've got your risk assessment standard, ISO 12100, and that goes through how to kind of carry out a risk assessment, identify tasks and hazard, identify risks, measure them and work out when they're at an acceptable level. But in terms of requirements on specific different devices and when those are suitable, you've then got a bunch of different type B standards around each individual type of device, and then you've got things on safety distances depending if it's crushing gaps, approach speeds, different sizes and speeds of different limbs. There's every possible fact and figure you could think of, and then a lot more in some of these standards. And then finally, there's your functional safety principles and unexpected startup and things that you also need to bear in mind. So there's quite a lot to think about, but I'm going to try and explain that maybe it's not as complicated as they sometimes make it seem. The other thing to remember behind this is that there's also then a bunch of type C standards. So if you have very specific machinery, it's quite likely there's going to be a specific standard for that machinery as well. So you get type Cs for balers, you get type Cs for automated storage and retrieval machines, and they're going to have more detail to help you decide on risk reduction measures, and sometimes have kind of exact requirements of, on this bit of the machine you should have this and this. So type C standards are a great place to look, and if you can't find those, then the requirements in these are great too. Just to let you know, a little bit of housekeeping while we're here, there should be a Q&A button probably at the bottom of your screen. I can't remember on when you're an attendee, but if you do have any questions, feel free to ask away. We'll have a little Q&A at the end, and any we don't manage to get to, we'll make sure to catch up on email afterwards. So please do shout out if you have any questions. So risk reduction, we're here to talk about risk reduction. It's a bit of a weird term. It's replaced safeguarding measures and things because you can't really make things safe, and all you're really doing is reducing that risk. So it's slightly more accurate, slightly more of a mouthful, but there we go. So you've done your risk assessment, you've determined that you have some risks which are too high, and so you need to reduce it. In order to know how to reduce a risk, you need to know what risk is, which is severity of harm times the probability of occurrence. Probability of occurrence can be broken down further into exposure, occurrence, and possibility of avoidance, but that all kind of comes into how likely is that accident or hazard going to happen? How badly is someone going to get hurt if it does happen? And you can kind of see if they're not likely to get very badly hurt, it maybe doesn't matter so much if it happens, it's fairly low risk. If they're likely to get hurt very, very badly, even if it's not very likely to happen, you need to reduce that risk. So that's the kind of basis of what risk is. How do you reduce it? Well, ISO 12100 has kind of your 3 steps. And these are, if you're going to take anything away from this, this is probably the most important part of the presentation, really. So that first step is inherently safe design measures. And that's really key, is that first thing you want to do is just make it safer. Remove the hazards completely. And I'll go through a couple of ways of doing that, because it's not just a case of, oh, you can't use this machine because it's too dangerous. You know, we understand in machinery safety that you need machines, and that machines cannot ever be inherently safe. They can be pretty dangerous, in fact. So, but if you can do things to make it safer, kind of inherently by itself, remove that interaction. Step 2, safeguarding and or complementary protective measures. And that's probably going to be the bulk of this, because that's the most interesting kind of area and what we also have the most experience in. So that's going to be your guards, your protective devices. That's anything that kind of physically removes a person from that risk. So whether it's a fixed guard or whether it's an interlock that ensures that you can never be next to the hazard. So as soon as you open a gate, the hazard turns off. You can't ever physically get near that hazard by some means. That's a safeguarding or complementary measure. And then finally, if you really can't reduce the risk far enough using inherently safe design measures or safeguarding, then you use information for use. And that's going to be things like training, that's things like PPE, that's things like putting a sign up saying, oh, this is dangerous, don't come near it. Which obviously all of those things can be ignored very easily and are definitely not your first choice, but they can be useful for that last little bit of risk if there's no other way of reducing it. So now we're going to run through kind of each of these things in turn, spending most time on that safeguarding and different considerations for when you are choosing your safeguarding measures. So firstly, as I said, most important is inherently safe design measures, because they're the only way to kind of to permanently eliminate and reduce the risk, because even well-designed safeguards, well thought out training programs, they can fail, they can be defeated, they can be ignored. Whereas if it is inherently safe, it's never going to fail, it just is safer. So first things to think about geometrically. So as I said, it's obviously if you can just use a less dangerous machine, great, go for it. Assuming that's not going to be possible, can you reduce blind spots, make it less likely there's going to be someone start up the machine? Can you increase gaps between rollers to make it, to remove that crushing hazard? Can you make it more ergonomically safe? Because remember, risks aren't just cutting your arm off, but actually long-term back injuries from having a control station a foot too low is also a risk that you could inherently remove. Physical aspects. Do you need it to be, that press to be going at 5 meters per second or something? Could it go slower? Could you make it such that that big thing that's going to hit someone just leaves a bruise if it happens to go wrong, rather than it smacking them in the face? Things like that. Can you reduce things inherently? Considering maintainability is really important as well. Thinking about if you can oil something from the outside rather than having to go in near the hazard very often to lubricate, things like that. So just a list there of things to consider. How can you inherently reduce that risk? And then if you can't, that's when you start looking at safeguarding measures. There's a variety of different things that come under safeguarding measures. The most obvious are going to be your fixed guards, which I'm a big advocate of trying to make things as least complicated as possible. If you don't need to get in somewhere, just chuck a fixed guard on it, but we'll discuss that in a little bit. Movable guards is the next option. If you've got movable guards, you're going to need some kind of interlock. If you don't want movable guards, you're going to need some kind of presence sensing device, or sometimes in conjunction with guards as well. And then there's some other things as well. We'll kind of talk about those other controls and sensors and buttons of various descriptions. So there's lots of different things. So guards being the top of the list. Oh, so sorry. Things to consider when you're choosing, because obviously there's a big choice of different, not only different types of devices, but then within that, the different devices. So things to consider when you're choosing your risk reduction measures are things like, do you need access? If you need access, how frequently? What type of access is it? Is it one arm being put into a hatch, or is it that someone has to go into an area where they could be completely hidden? There's a massive difference. Is the machine going to stop immediately if you turn it off? Does it have a rundown time? Do you need full isolation? And then also things like the environment are really important, because your different devices might work better or not as well depending on the environment. And then again, there's things like connectivity. Do you need super fancy connected things? Is that going to actually save you money, or would a fully mechanical system be better? And it's different for different people, and that's what I'm going to try and hopefully show you, is when it's a benefit, when it's not, what you can consider. So selection of guards. When you are choosing your guards, you're going to need guards on a lot of applications. What's it made of? Is it suitable for the environment, both, if it's indoors or outdoors? Is it in a corrosive environment? Are things going to get flown out of the machine? Does it need to be solid? Or can you have gaps in your guarding? How easy are they to use? Malcolm's going to talk about that in a little bit, but things which are difficult to use are going to make people not want to use them. And that's a really key thing to consider when you're looking at risk reduction measures as well. Visibility, again, you can see here you've got a completely clear guard, which is great. You've got things which are, if you've got dark mesh, you can see through them really well, as you can see in this picture. If you've got a light mesh and a really tight mesh as well, then you can't see as well through it. And sometimes that's really important, sometimes it's not. So on this one, it doesn't matter. But on this one, obviously, it's really important that you can see through the guard. So do you need to be able to see through the guard? How's it fixed? Again, Malcolm's going to mention security fixings, but also, is it high vibration? Do you need to consider that? Anti-vibration fixings, things like that. And then again, heights and gaps, minimum heights, maximum gaps underneath, between things. There's standards for all of these, but it's just things to be thinking about. So you've thought about it, and you realize you don't need to access an area. You don't need to get into this bit ever at all. Put a fixed guard on it. Don't make it more complicated than it needs to be. Chuck a fixed guard on it, sorted. You are fully removed from it. And in the unlikely event of needing maintenance, you're going to have a separate risk assessment, which will probably involve full isolation before you are able to remove that. But for most, if you're not needing to access an area very frequently, you only need to get in there once a year or something, just put a fixed guard on it. That's my advice. However, a lot of places you do need to get into, and I'm not pretending that that's not the case. So if you do need to get into places, you're often going to need an interlock to allow it to be safe to use a movable guard. Lots of different types of interlocks, and again, suitable for different situations. When you're looking at ISO 14119, which is the standard about interlocks, they currently have a table which goes 1 to 4. If you look at the next version, which should be being released any minute now, that may take another year or two, but it is in development. They're going to move mechanical trapped key out. It's currently in type 2, which is kind of doesn't make any sense. So it's going to be its own type, which is why I've written it down there at the bottom. But you can have type 1s, which kind of press against something else. You can have type 2s, which have some kind of tongue. You can have non-contacts, and non-contacts can either be uncoded, where any actuator will work, or they can be coded, where it has to be the right actuator. And then there's trapped key as well. And as you can see, these are all kind of suitable for different environments, different situations. These obviously are nice and there's no mechanical parts, so maybe good for environments where it needs wash down or something, especially made of stainless steel. And there's lots of there's lots of different versions, and it's going to depend, which we will go through some more. But while we're on this list, you'll see that it says coded and uncoded, and within that coding, it actually can go up to things called high coding or low coding, depending on how many different codes there are. And about that, I think that kind of leads me on nicely to hand over to Malcolm Sharp, who is on the committee which is rewriting this standard, and is going to talk to you about motivation to defeat, which is a really important subject when we're talking about safeguarding devices.
Yeah, thanks, Eve. It's become a topic that has kind of dominated my working life at the moment. A study back in it was probably about 2006, 2007, carried out in Germany by independent bodies, found that 70% of interlocks were defeated on site. And as a result of that, we've seen an amendment to 14119, then a rewrite of 14119, and 14119 is again being rewritten. That's the interlocking standard. And I think it's going to have about 10 pages devoted to motivation to defeat. So for us, it is about understanding why an operator would need to defeat a safety system. And that means really liaising, working with everyone associated with that machine to understand the processes they carry out every day. Most cases, my experience, most operators don't deliberately go out of their way to defeat systems for the sake of it. There is a legitimate reason. They're trying to do a better job. They're trying to get output. And you really do have to get back to the basics of root cause of understanding why they are defeating the system. The standard focuses a lot on how you prevent them defeating the system. There's a lot of talk, and Eve mentioned earlier that I would talk about security fixings. One of the most common questions I get asked is, do I need to fit security screws? Do I need to weld the lock in place? If there isn't motivation to defeat, you don't need to do that. Get back to root cause, find out the problem. Band-aid fixes just push the problem further along. So if we are using security screws, what's the next step an operator will take if he feels he has to defeat the system? So we encourage you to really get to understand what the operator needs to do, how he needs to work, how he needs to do his job properly. So one of the things, and Eve tires of me telling this, one of the great stories I have goes back to a steel plant in Australia, where at the point they were doing the risk assessment, they identified one of the tasks was to apply oil to a specific part of the machine. And to do this, the operator had to stop the machine, enter the safeguarded space, and apply the oil, come out of the space, restart the machine. So that was taking time to do. So it also presented a risk. Obviously, the machine had to be stopped. If it wasn't stopped, there was a hazard there. So they got around this by using a plastic pipe from outside of the safeguarded space into the machine at the point where the oil needed to be applied, and then applied oil on the outside of the machine. So a huge win for them because it increased productivity. They weren't stopping the machine, protected the operator, and it was a real win-win situation, improving productivity, keeping people safe. What's not to like about that? So I'd encourage you, and I think we might have a handout, we might be able to email out after the webinar around this motivation incentive to defeat, a white paper we've created. This is really the basics. You implement the basic measures laid out in your risk assessment process in 14119, in 12100, and then ask that question, does motivation to defeat exist? If it does, then you have to look at how you eliminate that. And that might be exactly what I've just described, where you find another means of carrying out the task without the operator being exposed to the hazard. If it doesn't exist, you're fine, you're done and dusted. Again, so if we do have that problem where we haven't removed that motivation, you then have to look at additional measures. And those additional measures are things like security screws, are things like additional guarding, etc. It's finding, I mean, non-detachable is the terminology that will be used for devices. So essentially, if you can't remove that motivation to defeat, you have to shield interlocks, make them non-detachable, etc. And all that does in my mind is just pass that problem down the road. If someone needs to get in, they'll get on a ladder and climb over the fence. So root cause analysis, remove the need for them to do that. That's the key to all of this. One final point from me is that not only is motivation to defeat going to take up a very large part of ISO 14119, it will be introduced into ISO 13849, which I find a little odd, but it will be there. In what format, I don't know yet. I am currently on a working group, of a sub-working group of that working group, to look at motivation to defeat. I suspect it will be a smaller part than 14119, but nevertheless it is considered serious enough that it's going to appear in multiple standards. So thank you for listening to that, and over to you, Eve.
Thank you. Yeah, so motivation to defeat is a key part when you're looking at your interlocks and how you're going to fit them and how your kind of whole safety system works. Another key question when you're looking at interlocks is going to be, do you need guard locking? So guard locking basically holds the gate shut. So rather than being able to immediately open the gate whenever you want, it's going to hold the gate shut until a certain point. And for safety reasons, the only reason you ever need guard locking is if the overall system stopping performance is greater than the access time. So that's basically if you open the gate, which immediately sends a stop signal to the machine, if by the time from you doing that action, by the time you reach the machine, if it is in a safe state or the hazardous motion has ceased, then you don't need guard locking. If, however, you were able to open the gate or turn off the machine by a button or whatever, if you can reach the machine while it is still dangerous, so if you've got a rotary saw or something, if that can still be running, even so there's no power to it, but obviously some things take a while to turn off and to run down. If there is that rundown time that's longer than the time it takes you to walk over there, then you're going to need some kind of guard locking to hold that gate locked until it is safe. So that's kind of hopefully makes sense. Basically, you have to keep the gate shut until it's safe to open it. There are other reasons you might want guard locking, which are kind of non-safety, so process control. A lot of processes, if you just open a gate and therefore turn them off, so if that interlock immediately sends a stop signal, if that stop signal goes at certain points in the process, that's going to cause massive issues. You might have to redo that whole cycle. It might ruin some product. It could break the machine. Even if it's not unsafe, it could cause massive issues. Another reason you might want guard locking is access control, if you want to make sure only the right people can go in. So it's basically the right people or the right point in the process. You might want guard locking, but the only reason you need it for safety is if you can reach it. If you're able to reach it while it's still hazardous, then you're going to need some kind of guard locking. And then if you have guard locking, remember that's locking the gate shut, so not some kind of non-contact where actually you can open the gate any time, but it is locked shut. That then brings up some other issues. So you may also need some way of releasing that guard locking in an emergency kind of situation. Most common of that is going to be escape release. So if someone has managed to get trapped inside while it's locked, then you're going to want an escape release, which is usually a handle or a kind of push pad, which allows you to exit and obviously initiates a stop command at that point as well. There's other ones which are emergency release, which is kind of some kind of knob on the outside which allows you to override that guard locking. It's not often recommended because it means that you can override a safety function. Occasionally it's required for fire risk or if there's a certain risk which makes it worth it. But again, risk assessment really important to decide if that's a sensible option or not. Auxiliary release is probably more common. So if there was some need to get in and override it, but it's using a special tool which is kept by a supervisor, or there's a special process for getting hold of that tool. So yeah, if you have guard locking, you may need to consider whether you need supplementary release by some means. And while we're talking about escape release, which is if someone has managed to get trapped inside, that leads me nicely onto my next thing of whole body access. So whole body access is any time when you can be kind of completely inside an area. So not, if it's a tiny area where you can't actually shut the gate behind you, then it's not whole body access. But anytime you can get fully inside, it is whole body access. And actually the robot standard gives a really, really good kind of step-by-step instructions of what to do when you've got a whole body access situation. Weirdly, the ISO standards don't have any particular place where it makes it really clear, except the robot standard. ISO 14118 has a lot of bits about it, but no kind of specific sections. So anyway, I'm going to run through this one because it's the easiest to follow. It definitely doesn't contradict anything else, so don't panic about that. First option is give a clear, unobstructed view of the safeguarded space. And obviously that's great if it's a small area from where you're going to reset. If you're able to see the whole area, then you can probably tell that there's no one in there. If it's a nice small area, definitely no one can be hiding anywhere, then that can be safe in its own way, as long as people know that. The next one is to use presence sensing devices. So you can use some kind of presence sensing device like a laser scanner or a safety mats or anything like that to know when there are operators in the area. This can be great in certain areas. It can also be problematic if it's a really big area. That can be very expensive if it's a complicated shape, because you've obviously got to make sure there can't be any blind spots, there can't be anywhere someone could be hidden, people can't be standing on things to avoid safety mats, things like that. And then the next option, kind of broadest, if you can't definitely make sure that there's no one in there kind of visually, either with eyes or with presence sensing, the next option then is to use other protective measures, which usually looks like either a safety key. So measures to lock a guard in a gate in the open position is going to be a safety key or interlock blocking. So something which you take in with you, either you've put a padlock on the gate or you've taken a safety key as you go in using that trap key technology. And that gives that control to the person going in while they have that with them, either while their padlock is on the gate or while that key is in their hand. They know it's not possible to relock that gate, giving that personal control to the person going inside. And then finally, if you kind of can't do it by any other means, the last option is to have a warning signal or some kind of "it's about to start, you should probably get out of here" signal, which again, as we've discussed, we'd rather prevent it from happening in the first place. So giving them that control with some kind of protective measure rather than just warning them. But as a last resort, it's not a bad option. It's better than nothing. So again, as I said, 14118 has bits on it. So it has locking devices for this sort of situation. It just doesn't specify whole body access in a weird way, but that's a different issue. So anyway, it also mentions trap keys, it also mentions padlocks and lockable housings. So as I said, personal control, giving that person that control over it, and then maintain stop commands using key operated stops or latching. Basically, locking is a key part of this, and making sure that that gate cannot be shut and the machine cannot be restarted until the person who's gone in has come out and is happy with that. So yeah. Then another consideration when you're talking about any kind of devices, so not just interlocks, but any kind of devices, is going to be the environment. Is it a washdown area? Do you need it to be stainless steel? Do you need it to meet hygienic requirements? If it's outdoors, is it going to have serious temperature differences? Is it going to have rain all day, every day? Depending on where in the world you're installing it, these could be different issues. Maybe it gets really, really hot. Probably not an issue here, especially today, but there's different considerations depending on the environment. High vibration, a lot of electronic devices don't enjoy high vibration. Maybe you want to look at mechanical. If there's lots of dust and dirt, I mean, I've got a few pictures here. there are some interlocks under there, I promise, is in a concrete manufacturing place, and you know, everything's covered in a thick layer of dust. This is in a paper manufacturing, and everything is very, very wet, very dusty and dirty again. So considering those different things, I've put a few pictures here. Explosion proof, again, explosive atmospheres, you've got to be really careful of what you're putting into those atmospheres. If it's very dusty, are light devices going to have issues? If there's, also I haven't put in here, but there can be electromagnetic interference, things like that. Maybe you want to avoid sensitive devices. So there's lots of different considerations to think about with the environment. Again, I'm just trying to point out, hopefully, some things to consider in the fact that there are lots of different options available. Another consideration is going to be how you actually attach some of these devices. So you can have a fully mechanical system, so this trap key system here, there's a switch, and then the rest of this, so a key exchange and the door locks, are all fully mechanical. So this is great if you want to retrofit something, if there's massive distances involved, if there's no electrical supply on the gates, if there's no wiring, and that wiring is going to be an absolute nightmare to put in, then all you have to do is have a switch wired into the control system somewhere on a panel, or it can even be a mechanical bolt going into a disconnect or something. And you can isolate any different type of power source, so you can have different power sources all coming together into an exchange, and then again, everything's mechanical, can be really great. Sometimes, however, you might want that control directly on the gate, in which case that's not going to be what you want. You're going to want instant access maybe, and then you're going to wire to the gate, and you can have that there. You can also add buttons on, you can do lots of different things at that position without having to worry about a control panel in a different room. So different options, different applications. Kind of the next step up is going to then be having it Ethernet connected. If you've got lots and lots of I/O, you've got lots of maybe long distances, then having those big cables going out to all the different control stations, all the different lights and buzzers and gate locks, that can get really, really expensive quite quickly, and you can have some very, very chunky cables coming back into your cabinet. However, if you got Ethernet connected things, everything can kind of plug into itself. Just get one power and one data cable, and you can run loads of stuff off that, and it's nice one little cable. So again, that can very quickly actually become a lot cheaper, depending on your application, up to you. Obviously, if you've got Ethernet connected, you can start adding in more functionality. You can have RFID badges, you can have data coming back into computers or into the cloud. You can see what's happening at a different kind of level. So again, but in some situations, fully mechanical is better. Some situations Ethernet, some situations wired. It depends on the application. And what I'm trying to show you is, and hopefully it's working, is that there's lots of different options. So we are getting nearly there, I promise. So presence sensing devices. We talked a bit about interlocks, but presence sensing devices, if you don't want movable guards, or in conjunction with those guards, are a great option as well. Considerations when you're looking at different presence sensing devices. I've got a few pictures of different things. You can have beams, you can have curtains, you can have laser scanners, you can have radar, and then pressure sensitive things as well. You've got to think about your safety distances, because obviously there's no physical guard. So you've got to think about, once someone has gone through that barrier or into that area, how long is it going to take them to get somewhere? Is the machine going to be safe by the time they reach it? So that's the same as your guard locking, but without the ability to guard lock. So you have to make sure someone can't reach the hazard before it's safe. You've got to think about detection, blind spots. If there's whole body access, same things apply. And making sure that you can't accidentally or intentionally avoid being detected when you're meant to be. Again, environment, and especially with light sensitive things. Dusty environments, reflective surfaces, variable light conditions can be a problem, but it depends on the application, depends on the product, can be some options which will work really well. And also muting, make sure someone pretending to be a box on a conveyor doesn't actually get mistaken for a box on a conveyor. Things to think about. And then our last bit on controls and devices is kind of, there are a lot more safety related controls to consider as well. And there's going to be requirements around each of these, and each of these actually has their own standard with all of those requirements in as well. Emergency stops you'll be familiar with, but there's specific requirements on not just the shape and the color, but also where they are and how many you need in different areas. Resets, again, lots of requirements around how they work, and making sure that resetting never restarts the machine is kind of the key one on that. Two-handed controls, you get sort of things over the top of them usually, or rings around them, because you've got to make sure you can't use your elbow and your hand and reach the other arm out. Can't use your knee. Lots of things to consider there. But again, if you read the standards and find those requirements, it's almost like someone else has thought of all these things, and you just have to make sure you take them all into consideration. Enabling devices, again, super useful if you do need someone to be in a dangerous area, because if they either drop it or squeeze it too hard, it immediately stops the machine. So some really useful little things that you can use as well. And again, there's going to be requirements and suggestions in Type C standards of which are best in different areas, but hopefully pointing out some different options is useful as well. And then finally, information for use. As I said, it's kind of your last resort, can be really, really useful, but it shouldn't be the first thing you think of. It should be the last thing in your risk reduction arsenal, as it were. So you want to put signs up, say what the remaining risks are, because there's always going to be residual risks. Nothing is ever risk-free in industry. So what the risks are and what should be done against them, PPE that you need, you're going to make sure that you've got signs and signals as required. A key thing to make sure is that your fire alarm doesn't sound like your brake thing. So if there's a buzzer, people know immediately whether it's, oh, it's lunchtime, or, oh, there's a fire, I should probably get out of here. So making sure that that's obvious, and then getting your signs and markings and requirements. Worth noting that just putting a sign that says danger is not useful. You should be saying what the danger is and what you should do to avoid it. Just saying danger is not going to help anyone. And then the other part of information for use, kind of for manufacturers more than users, is going to be the manual, and it's really important. And there's a massive list of things which have to be in the manual, in the handbook. But also, when you're thinking about it, think about who it's going to be read by, how you can read kind of more, how it can be more useful. Are there pictures? Is it useful font? Things like that, like make it as useful as possible is a really key point. And that, I apologise for going slightly over the half an hour that I promised, but hopefully you're still with me. But that is all I was going to try and get through. And now I think we've had some questions come in, which is great. And I think, Malcolm, were you going to run through the questions?
Yes, I was, Eve. So we've got a question that's come up quite a few times when we've run this seminar around the world. Do you need to have a qualification to carry out a risk assessment? And I've heard that question a few times now.
Yeah, it's a really interesting question because, in fact, in the American standards, it specifically says a qualified person, but qualified person just means that you have experience and the relevant knowledge. There is no specific qualification you have to have. And actually the most important people to be involved in carrying out a risk assessment are the people using the machine themselves. So the operators, the maintenance personnel, because they know what's happening and what the issues are and where those dangers are. So someone with some experience is really, really important, but actually the people experienced on the machine is more important.
Excellent. So there's a couple of questions here that I think are kind of linked, and I might just jump in and take these if you don't mind, Eve.
You go for it.
So I'll ask both the questions were asked in the Q&A, as have all of them. But we've got a comment in the question probably. One thing to mention is that machine maintenance is different. There are different risks compared to those for an operator. So I think that's an excellent question, and I think it ties in with another question from the audience, which was, can trap key, which has three-phase isolation, be used for maintenance activities? And the reason I think they link is they go back to one of your slides relating to ISO 14118. So for me, quite often I have seen maintenance activities actually remove guarding in order to carry out those tasks. And obviously once that's done, a standard interlock system, safety system, isn't going to do its job because you can just walk straight in. ISO 14118 does actually stipulate that trap key interlocking devices can be used as locking and securing devices. And ISO 14118 is specifically about the prevention of unexpected startup. And whilst it doesn't say it is specifically for maintenance, it is pretty much aimed for maintenance tasks. We don't talk a lot about 14118 in the safety world, but it is a useful standard. It could have done with a better update than the one that it had a couple of years ago, but it is a very useful standard. If you haven't got it, it's worthwhile having a look at it. So yeah, definitely maintenance is very much a different task than operational cleaning or anything along those lines. So yeah, certainly please have a look at that standard 14118. Right, so what else have we got in here then? Another interesting question. I've heard this put a different way before from the audience. Where do performance levels fit into risk assessment, Eve?
Oh, that's also a very good question. And I actually don't even mention performance levels in my risk assessment presentation very often either, because performance levels kind of come after that. So performance levels are functional safety and related to the reliability of your safety related part of a control system. And they actually kind of come after this because you do your risk assessment, find all the risks, work out what needs to be reduced. You work out ways of reducing those risks using kind of the devices and ideas that I've shown you today. And then if any of those are a safety related part of a control system, then you work out how much risk those specific parts are reducing, which will then give you the required reliability, which is your required performance level. So instead of, a lot of people seem to think that you kind of start with what your required performance level is, but really it's actually the last part. So you've worked out what the risk is, how big the risk is and what the hazards are. You come up with your ways of reducing that risk of, I need an interlock on this door. And then once you've worked it out, you know how much risk that interlock and the associated safety related part of the control system is reducing. And from there, you can then know what performance level that interlock requires.
Excellent, thank you, Eve. And that is a common thing I hear. Often when I'm out on site, the first thing people ask me is, what performance level do I need to be, without going back and doing that initial risk assessment? Yeah,
exactly. The required performance level depends on the amount of risk that bit is reducing, not what the machine is.
Yeah, very much.
So I think because we're running over, just to keep it within the 45 minutes, I'm going to jump to our tiebreaker question.
Excellent.
So on the next slide, there's going to be a question. And if you think you know the answer, if you write the answer into the chat, you'll be in the running to win a personalized key. And so that question is, what is the first step in the risk reduction hierarchy? It was quite near the beginning, but what was that first step you should always try and do before you start coming up with ingenious solutions? If you think you know, if you put it in the chat, so what's that first step of reducing a risk, if you can, to get it down? Looks like we've got a few people who know what they're doing. Awesome. And I think with that, I was going to hand back to the Underwoods team to kind of close us out.
Okay, thank you, Eve. I'm sorry, guys, I missed a bit of that because I had a bit of a drop out of my internet here. But what I would like to do is thank Eve for that very interesting, informative presentation. What it's done to me is reinforce the need really for a robust risk assessment. And that robust risk assessment will lead to the selection of the correct hardware solutions, and it is very, very important to design the correct safety-related control system. Now, at Underwoods, we have over 30 years history to help history and safety to help and support all our customers to make sure they've got solution. We have a national coverage, as you can see from the map, and we are in a position to support everybody locally. So we'd like to help support you in your design of safety solutions. So on that note, I would like to thank you all for attending today. We appreciate the time you spent with us. Please contact us for any further information. Thank you.
Thank you, Phil.